Hello, back again with scenario 2. Before, they were asking for the kinetic coefficient, right? Let's say they want to know the static coefficient, and all you have is theta. Is it possible? Yes. Let's just kind of derive it, just real quick. We have an angle theta here, an object, force of gravity acting down. I'm going to replace it with its components. So force of gravity perpendicular, which obviously has a equal but opposite normal force, right? And then force of gravity parallel. And here's my other stuff. And here's the thing about static coefficient. Static means it's not moving. So if it's not accelerating down the ramp, then that just must mean that force of gravity parallel is equal to the opposite of the friction. They're equal, right? So what I can do here is I can use it to my advantage. First, I'm going to write down the universal equation that force is equal to the coefficient times that, which is equal to mu times negative force of gravity perpendicular. So what I have is that the sum of the forces equals 0, right? It's not accelerating in any direction, because this cancels this, and that cancels that, right? So the sum of the forces equals 0. I'm using that mass times acceleration is equal to 0, right? So what are the forces acting on it? Well, there's none. There's no forces, net forces acting on it. Well, there are forces acting on it, but net forces is none. So I'm just going to mess around with this. I'm just going to say, well, of course we know from earlier that this is going to be equal to mg cosine theta, right? So what we have here is that here mg sine theta is equal to negative, and you know what, we write f is negative mu mg cosine theta, right? Yeah, cosine theta. And so negative times a negative becomes a positive, so we get that mg sine theta is equal to mu mg cosine theta. Then we can divide both sides by mg, and we get that sine theta is equal to mu cosine theta. We divide each side by cosine theta. And we know that sine over cosine is of course tan theta, so we see that mu static is equal to tangent of theta. Now keep in mind, this is only for coefficient for static. That means that this block, or whatever is sitting on this inclined plane, is not accelerating down. It is just standing still. So for static coefficient, it's just tan theta. But if they give you an acceleration, like if they say it's inclined at 45 degrees and it's accelerating 5 meters per second down the ramp, meters per second squared down the ramp, then you need to remember the equations for kinetic coefficient, which was the video dealing with canceling all the mass and all those fancy equations. So hopefully this helps.